All right. Hello, everybody. I hope you are enjoying the conference. So my name is Jean-Louis Monteiro. Oh, don't break the chair. So my name is Jean-Louis Monteiro. I live in France, and I'm working for a company named Tomitribe. I've been working over the last couple of years on payment systems and leading with a lot of security issues, and that's one of the reasons why I want to share some of the experience and the lesson learned. I'm a long-time Apache contributor. I've been contributing as well to MicroProfile and the Jakarta IE specifications. Today I'm here to speak about one of them, which is the MicroProfile JWT. Today I'm going to be very quickly speaking about the microservice architecture. It's really a few slides because that's not the main purpose of the talk, but still that's important to understand what are the new challenges with the microservices path. I'll be also sharing some of the security options that I've seen so far while I was doing some professional services on the customers, I'll be of course spending more time on JWT, and at the end of this presentation I have a small example on how to set up MicroProfile JWT using one of the available implementations. I'm sorry, it's not going to be a Liberty profile, but it's going to be Apache TomEE, which is one of the projects I've been contributing to for quite a while now. All right, microservices. So for old guys like me and probably some other colleagues, it's nothing else than SOA with a more sexy word. We used to be building our architectures using kind of a monolithic architecture. SOA is a system made of 4 components that we used to put together inside the same big application. It definitely has some benefits. One of them is basically it's very simple. The communication between all the small components, it's very easy. It's like inside the same JVM. But it definitely comes with a set of drawbacks as well. One of them is like all the life cycle is tied together. So basically, every time you want to do some updates in one of the components, you obviously have to build everything again and deploy everything again, which leads to many issues in production, and most of the time it leads also to downtime because it's kind of the big bang deployment issue that you have to face. It also comes with some benefits. One of them is also the scalability. So the way you would scale this kind of system is very easy. You take the full package and you're gonna replicate that as much as you want, so that you can really scale out. This is very easy, but doesn't allow you to take the most of your system most of the time, because if you need one of the small component over here, which is more used than the other ones, you're going to have to still duplicate the whole thing, and therefore you're going to waste some of the resources. In terms of security, it was kind of very easy to secure this kind of system. So usually when you are building a system and you want to secure the system, there are 3 things that you need to do. The first one is to identify the caller. So who is the guy actually calling you on the other side? You need to know what he can do so that you can do some permissions enforcement. And the third thing that you have to do is also to propagate the security context, so that when this component needs to interact with this one, you can pass through the security context. So all of that is kind of very simple inside big monolith applications like this one, because obviously you kind of share everything inside the same JVM and the same thread, so it's very easy. So in terms of what we can expect from the microservices now, so we can expect, we can see the benefits from two perspectives. One, which is the technical one, and the other one, which is the organizational one. At least that's my opinion. In terms of the technical perspective, the developer one, the DevOps one, it's more cloud friendly, so you can more easily deploy small pieces on the cloud using Uber jars, like it's been mentioned before. You can really take the most of the container approach, like Docker, so that you can isolate all your components. And also it's easier to scale out and shrink down, so that you can really during the Black Friday or whatever peak you have, you can really scale out your system. In terms of the organizational perspective, I think it fits easier the agile methodology, because you get smaller teams, smaller projects, and you can more easily run them in parallel. There is also the organizational issue that I've seen many times in companies, like what I call the people-driven architecture. Like every time you get a new team and the organization changes, then you tend to add a new layer, which makes the whole thing more complex. If you have smaller sets, you get a chance to avoid the Conway laws. But there are many new challenges. Some of them have been explained during the previous presentation, like the resilience, the monitoring with the health check. I'm going to be focusing on this one, on the security only, and I'm sure that during the day you're gonna be having more feedback on the other pieces, and if you don't, then I'm happy to sit down somewhere and have a discussion with you. So in terms of security options, so I've seen in companies and in many projects a subset that I tried to write down in this slide. The first one, which is still the most used, unfortunately, is the basic auth. I'm quite sure that probably some of you are still using that inside your companies. Maybe yes? Yep, basic auth? Yeah, sure. And we've seen with some major actors like Google, Facebook, new specifications coming, like auth 2, OpenID. Facebook and JWT are more heavily relying on JWT, which is quite common when you have some kind of user-oriented flows. Amazon, on the other side, is using more what we call the message signing with kind of an HTTP signatures kind of approach, but it's more B2B kind of communication. And I've seen so far also many in-house solutions, because most companies think that they can do things more easily if they do by themselves, which at the beginning it's pretty much always true, but after a while it becomes like usually a nightmare to maintain. So over the next couple of slides, I'll be showing how to use JWTs and how to secure microservices using JWTs. To do that, I'll be relying on this basic architecture, on this baseline architecture. So we've got like a backend set of services, and let's say that to deliver our big high-level service, we need to do like 4 internal calls, and then on the consumer side of things, let's say that we have 1,000 users, and each one of them are not really very crazy on their computer. They're only doing 3 TPS, which brings us to 3,000 TPS on the front-end side of things and 12,000 TPS on the back-end side. So that's the use case I'm using during this presentation. And I'll be trying to explain what the different security options bring and what are their drawbacks and their benefits. Very quickly, because I've seen some hands raised when I ask. In terms of basic auth, it's still, as I said, very commonly used today. So I'll be spending a few slides and a few minutes explaining why you should not do that and why you should be looking at other options. So in terms of how it works, so it's very simple. It relies on kind of a token, let's call it this way. And the way you get this token is basically you're going to take the username, the password, you're going to base64 encode this, and then you can put that into your HTTP headers, and on the consumers, on the server side of things, you can just get that header and then do your security checks. If we get back to our baseline architecture, then we've got our 1,000 users, and they are doing like 3,000 TPS calls. And on the back end, let's say that for now we don't have any authentication, which is very bad, I know, but let's assume that for now we don't. So what we end up with when we use basic auth is that we can send our username password 3,000 times on the network, which gives like a lot of chance to hackers to be in the middle and grab your username and password. And in that case, obviously your account is going to be compromised. Just a quick note, as I said previously, the username and password are base64 encoded, and that basically means that you can also decode it on the server side, and if you are in the middle, because base64 encoding is not really encryption. It's not at all encryption. So that's the reason why you should avoid the basic auth, because everyone in the middle can really very easily decode the username and password and then use the credentials. And well, if you have an LDAP to store your credentials, then this LDAP is going to be hit like 3,000 times, because every time you receive the header, you need to hit the LDAP to check the credentials. So let's say that now on the back end, we want to also authenticate the calls, which you should definitely do, because you don't want anyone on the back end to also be calling your backend services or stealing the information in there, just because the calls internally are not authenticated. So now if you start doing that, we're going to get like the 12,000 calls from the backend and the 3,000 calls from the front end hitting the LDAP, which brings us to the conclusion that what we've built is basically a single point of failure on the LDAP, because the more you're going to be scaling the front end part, and the more you want to get incoming calls, the more you're going to be burning your LDAP, and at some point, well, you're going to be basically killing your LDAP. This also shows that from a hacker point of view, it's very easy to do a denial of service attack on this kind of system, just because it's very easy also to make up username and password pairs, and then to start hitting your service. And the reason for that is that every time you receive a request, you have to go to your LDAP. So obviously, the more you're going to get requests, the more you're going to be eating your LDAP, and at some point you're going to be having a denial of service. So let's go to OAuth 2, because I think that's probably the most interesting thing that came over the last few years with the major actors. So essentially, what we want to do with OAuth 2 is basically exchange a username password during the authentication phase, exchange that and get a token that we're going to be storing on our devices. So it can be an iPad, an iPhone, or a MacBook, or whatever device you are using. So we're going to be exchanging the username password, storing the token here, so that for the next calls we're going to be only using the token. And the other benefit is that if at some point you lose your device, you are not going to compromise your account, because the only thing that the device has is the token, and at any time you can go to Twitter, Facebook, or whatever service you are using, and you can revoke the token so that if someone has your cell phone, you won't be able to really access your account. So how does it work now? So it works like in two different phases. The first one is the exchange, as I mentioned. So you need like an authentication phase where you're gonna be signing with a post. You're gonna be sending the username and the password. And what you will get back is like an access token plus refresh token pair from the server. So the server is going to basically validate your credentials against the LDAP or any other backend that you are using. It's going to generate a token that the server is going to store on the backend. So the tokens are stored on the backend, and then the backend is going to give you just the ID of that token. So it's basically a pointer that you're going to receive, and you're going to keep this pointer for the whole duration of the session. This might remind you something that you have been doing like over the last 20 years, because this is like very common on web applications. When you have a formula and you are posting a username password to the backend, you are basically doing kind of the same. On the auth terminology, they call that the ground type password. That's the small piece that you have at the beginning of the post. But overall, what we are doing here is what we have been doing over the last 10 or 15 years with the regular web applications. The only difference is that on the way back from the server, you get the access token and refresh token pair. In terms of usage, it's very similar to basic auth. The header is still the authorization header. The bearer is now what's going to replace the basic scheme, and therefore after what you're gonna send is now the token as opposed to the username and password. So this makes a big difference, because from now on what we're gonna send is no more our credentials. It's just a pointer to a token which is stored on the server side. So you can keep calling your backend service until at some point you receive a 401. So the 401 is basically when the token is going to expire, because we don't want to have like very long life tokens. We want to have them very short, so that we have to renew them very often from the backend. So when you receive a 401, you have to basically re-up your session, which is basically call the server and give the server the refresh token that we received during the first call and you stored on the client side. So you're going to be sending this refresh token, and on the server side, we're going to be verifying that the refresh token is valid, and if the refresh token is valid, then we can send you back a new access token, refresh token pair. So the access token is really a short-lived token that you're going to store on your device, and then you're going to be sending very often. The refresh token is something you're going to be storing as well on the client side, but you're going to be using that only to re-up your session. So that's just a reminder of the old pair I've got, the new pair I've got. In terms of the refresh token, some implementations, I think the IBM ISAM does not support the refresh grant, for instance. But most implementations have the support for the refresh token grant. So if you are looking for different implementations, and there are many of them, you should be looking at if the refresh token is supportive. If the refresh token is not, then when the access token is expired, you're going to have to re-authenticate again. So it might be a useful point to check if you are looking for an implementation. The other thing that you should be looking at is how many times can I use the refresh token to re-up my session. There are also different options in that regard. So over the last one year and a half, I've been working on an API gateway at Tomitribe, and we have been thinking about this refresh token, and we also look at the different options in the market, and we've seen so far that a lot of implementations are not really, well, a lot of implementations allow to reuse the same refresh token to re-up the session, which is good, but it also allows a hacker that is going to steal your refresh token to basically fork and create a lot of access tokens from one single refresh token. So at Tomitribe, what we've done is that we have a configuration that allows you to basically only use the refresh token once, so that if someone steals it, you won't be able to fork and create a lot of access tokens to reach you after and try to do an attack. So you should also be looking at those options to see what best fits your requirements. So what have we achieved with OAuth 2? So we've been able to basically avoid having the username password many times on the network, because we're going to be only sending that at the very beginning when we want to authenticate. And we're going to replace the username password during the upcoming calls by a blind token. The benefit is that this token is just a random number. It's just a pointer to record basically on the database on the backend, and therefore, if someone is going to steal it, you won't be able to reverse engineer the token and figure out what's your username and password. But also, I mentioned previously that probably it reminds you something. So the username and password post should remind you what you have been doing for years when you have a regular logging form on your system. And the token that you receive on the way back should also remind you that that's also what you have been doing with Tomcat when you work on web applications. So basically, on Tomcat, what you used to do is basically have a formula where you're going to post the username and password, and on the way back you're going to get the JSession ID, which is pointing to basically a map on the server side where you're going to be storing all your username, password, and security context that you're going to be using on the next calls. So what OAuth 2 has achieved so far is basically doing the same as the HTTP session and the logging form that we have been doing for a while. Aside that, now we have new terms. The first one is the ground type, which is the authentication phase. The second one is the token, which is what we used to call the JSession ID. So basically, we've got the same advantages that we used to have with Tomcat previously with HTTP sessions. We've also the same drawbacks, which is basically on the server side, you are going to be storing the tokens, and therefore you will have to lead with all the clustering issues if you have many instances that you want to share the same token. So in terms of baseline architecture, so now we've got still our LDAP at the top, which is going to be only used 1,000 times a day if you've got a session timeout of a day, let's say. And for the upcoming calls, you're going to be only using the tokens. So it means that now if you want to increase the load over here, you still won't be burning the LDAP, but you're going to be now checking your database. So what we've done with OAuth 2 is that basically we moved the load from the LDAP to the token store, which is where you're going to be storing all your sessions, right? Yeah, as a reminder, this is similar to the big HMAP that Tomcat has, where basically you come with a JSession ID, and then Tomcat is going to look for your session in the backend. So that's basically what we achieve with auth 2. So again, now if we start having authentication as well on the backend side, we're gonna be now burning the database just because every time you're going to be receiving this token and you want to know who is the person calling you, what he can do, then you will have to go to the database and load the profile each and every time. So again, we just moved the load from LDAP to a database, but we've got the same issues, which is, well, every time we want to increase the load over here, or if we need more backend services, we're going to be having troubles to really make this thing to scale up. So most of the time you end up by buying like very expensive solutions just to have like a powerful clustering solution on the backend. Well, yes, and at some point you might be also having some denial service issues, or you might end up by burning your system. There is also like a huge drawback in my opinion. So for people who worked on banking systems, I don't know if some of you did. Yeah, you. Maybe you are familiar with something named PCI. PCI is like a requirement when you need to store like cardholders or, well, let's say credit card information. So basically you need to have some audit trails where you're going to track what each person is doing on your system, so that if in 10 years from now someone wants to sue you and know, well, I want to know what this guy did on the system, just because I want to know if he could do it or not, then you're going to have to pull out all the audit logs from your backend system, right? And you're going to have to be saying like, this guy did that because he had the permissions at that time. And to do that, basically what you need to do is every time you're going to be logging information on the audit trails, you're going to be writing down as well the token, right? So that in 10 years from now, you can still go to the database and say, well, I'm going to load the token so that I can know who was the caller and what he could do at that time, right? So what you would need to do is basically extract the audit log and then reach out to this database and then load the token again. Which means that basically this kind of architecture really performs well at the very beginning because the database is empty, but over the time and in 10 years from now, basically, you're going to be like having a huge database with a lot of tokens stored in there, even if they are expired, just because, you know, in 10 years from now, you still want to be knowing, you know, who was the owner of this token, right? So this is a big issue in my opinion, and I've seen like many issues during the last 10 years when I was working in banking systems with other topics, but basically it's the same issue. So to solve this, we're going to be speaking now about JWT and what JWT brings. So basically, JWTs are JSON payloads. So basically 3 parts, a header, a payload, and a signature. It has like built-in exploration in there. And as I mentioned previously, there is a signature at the end that allows you to basically check that the token hasn't been changed in between. So you can really issue tokens, and when you receive them back, you can check if they have been changed. So it basically, it used to be something like this, and now it becomes something like this. So most people are afraid because they are bigger. Of course they are bigger. You know, it's always a trade-off when you decide about an architecture. You can't win every time. So basically, if you move from a regular OAuth 2 into an OAuth 2 plus JWT implementation, The trade-off is basically that the calls are going to be, you know, a bit more expensive in terms of network, because what you're going to send is a bit bigger. So that's the trade-off. In purple, basically, that's the header. In yellow, this is the payload, and the blue one is the signature. The header and the payload are base64 encoded, which means that everyone can still read the content, but no one can really change the content, because at the end there is a signature, and if at some point you change something in the token, then the signature won't match and the token will be rejected, right? On the header, so you're going to be specifying what the algorithm you used, which is RSA 256 in this scenario. On the payload, there are a couple of claims. So a claim is basically a key value pair in the payload over here. A couple of them are standard, like the issuer one, which allows you to identify where the token comes from. So if it comes from Facebook, from Google, from any other provider, you will be able to identify the provider. Then you've got the token type, the expiration date, the issue at, and a unique identifier, which is very important, because basically every token will have its own unique identifier, which means that even if you go and you authenticate with the same username and password, you won't be having the same identifier and therefore the same signature. So the unique identifier is very important in there. So it might appear like it's a small change, and it is, because the auth2 specification really speaks about the token, but it doesn't mention what the token is supposed to be. So it can be a random number, but it can be a JSON web token. And it makes a big difference, because previously what we had is like, we had on the server side all the tokens stored in a database, and we used to send on the client side only pointers. Remember, this is the HTTP session, which is this is the JSession ID. What we do now is that we're going to extract from the LDAP, when we're going to do the authentication, we're going to extract all the information from your profile. We're going to put that into the JSON, the yellow part, remember? And then we're going to assign this with a private key. The private key is private, as the name suggests, so you should not give the private key, and you never do that. Basically, keep the private key for you, and what you're going to give is basically the public part of the key, so that everyone that wants to consume the token can validate that the token is valid. But the private key is going to be stored only on the server side. Now what we end up by having is basically a JSON web token with all the information in there. What we're going to store on the server is no more the token itself, but it's only the pointer, the ID basically of the token, and it's going to be used basically only for revocation purpose, right? And what we send to the client is basically the full token, so that you are basically pushing the state from the server side to the client side, which makes the system on the server side more scalable, because you don't have to deal with all the clustering of the sessions and how you're going to replicate those tokens across the whole cluster. So now what we have is basically the client holding the state and the server side holding the pointer. I'll try to go very quickly because the time is going, I believe. How many? 5 minutes. So basically, the whole process is still the same. You're going to be sending username, password. You'll get back a token which is bigger, as we said. And for the upcoming calls, you're going to send the full token on the headers. So now what we have is something very different, because every time you receive the token over here, the first thing you're going to do is basically check the signature to make sure that this is a token you actually issued and the token is valid. So you don't need to be eating LDAP, you don't need to be eating the database over here to check if the token is expired or if it's valid or not. The only thing you need to do is basically check the signature, and if the signature is good, then you can let the call go on the backend. The other benefit is that when you pass the token on the backend side, you get the security context for free, so you don't have to also hit the database to get the information about the user and the permissions he had. So you get all the context for free. The only thing you need to do is as well check the signature so that you make sure that no one in the middle is going to change the token. But checking a signature, even if you use an algorithm like RSA, is very quick. And basically what's CPU intensive is computing the signature when you create the token the first time, but checking the signature with RSA is very fast. Also, it does not require, as I mentioned, any database calls, so that you can scale this part very easily if you need to have more load on the front end. And finally, if I get back to the PCI requirement about checking in 10 years from now, basically now what we need to do in 10 years from now is basically only keep the private public key on the server side, which you won't be changing a lot, so that in 10 years from now, if you read from the audit logs the token and you want to check if the token was valid and what information it had, then the only thing you need to do is basically check the signature, and for that what you need is only the public key, which means that this database is now no more growing forever. As soon as the tokens are expired, you can shrink down and remove them from the database. You don't need to keep them for a while. Just because the tokens, they have all the information you need, you don't need to be eating a database to get that information. So in terms of MicroProfile, I'll go very quick because the previous guy already spoke about that, and there are many presentations today. We are currently in version 1.3, and the version 1.3 has the JWT implementation in there. We are working currently on the 1.4, and on the 1.4 we're going to be bringing like a standard configuration and probably more interesting things for interoperability. I'll pass on the Y, and I'll be showing you a small demo about that. So for this demo, I've used a small application named Movie. It allows you to I'll make this bigger. So I made a small application named Movie Fun, so you can basically check out some movies, add some comments. And for the authentication part, I used like a regular formula, like the one you would do. And on the backend side, I used Apache TomEE for all the business logic and MicroProfile JWT. Just quick note, here is the link for the MicroProfile JWT specification. You have in there three things: the API, the specification, which is the PDF thing, and the TCK, which is the test compatibility kit, so all the tests that you need to pass if you want to be basically compliant. If I don't have time to go till the end, the example is available on Tomitribe.io. You can go in there. We have a lot of small libraries that you can use for free. Everything is open sourced. The Movie Fun example is in there. You've got a link to the GitHub repo. Everything is free. You can also fork it. If you have some questions, feel free to come over and ask. We are always happy to help. So let's go to a Movie Fun. So the Movie Fun is a simple application to authenticate. As I mentioned, we need a backend which is going to check the credentials and then issue tokens. For that, you have different options. You may want to pick up an implementation on the market. I've used the one I've been working on at Tomitribe for the last couple of months, maybe 1 year, which is named TribeStream API Gateway. You can also currently use it for free. We are in a beta state at the minute, so you can go to our website and download the Docker image and use it for free. I've already started the Docker image so that it's easier, and then I'll be now starting the movie fun application so that we can test the whole thing. So while the movie fun is starting, I'll go very quickly introduce you to our API gateway, which is over here. So there is a nice UI where you can log in, and then in this API gateway we've got the accounts. So I've created 4 accounts, sorry. Alex, John, Mark, and Nick. All of them have different permissions. Create, update, and delete. Alex is the one that has everything, and then the other ones only have basically either create, update, or delete role. What I've done also in this API gateway is defined a movie profile, which is an auth 2 profile. So our API gateway supports many authentication mechanisms, basic HTTP signatures, and auth 2. In this case, I've defined an auth 2 security profile. What's important in here is to, I'll make this bigger maybe so that you can read. What I've done over here is define an access token which is valid only for 5 minutes, so that we can see that it's going to expire, and then we can see that we're going to have to refresh it. So I think the time is over. It's noon, there is nothing after, I believe. So if you want to stay, I'm happy to go and finish up the demo. I think it's only a few minutes now. And then, as you can see, we have like a refresh token policy, which is 1 hour. During the demo, we can play with this and maybe also decrease the expiration so that we can see what happens. On the signature part, which is the very important piece on JWT tokens, I've defined a key which is a 2K key with an RS-256 algorithm. We have the public key available over here if we want to check. So what I've done is basically I've extracted this public key, put that on the MicroProfile JWT implementation. So every time you're going to call the backend, you can still check the signature. And for the sake of the demo, I've also added a couple of claims. So remember, the claims, they are the key value pair that you put inside the JSON, which allows you to, when you read that token, to build the security context and know who is who and what permission he has. So what I've done is that I've defined a set of claims. So obviously the username, the email. I've added the groups. So the groups, they come from the roles part of the account. So if the user has like create, update, delete, we're going to have 3 groups in the token. I've added a subject as well and an audience, which basically uses an external call to know what audience to use. All right, let's go to movies. It's not this one. Over here, I'll make this bigger as well. Here I go. I'll be instead using Alex maybe. So Alex, remember, Alex has create, update, delete, so I'll be able to load some sample data. So I've done on the back end a simple REST endpoint that basically is going to generate a lot of random data. So don't be picky on the names, it's just random data. So I've got a couple of movies over here. Now if we go and we open, I think I can make this bigger as well. If we open now the developer extension of Google Chrome, and we start navigating on the pages, we'll see that on this call, for instance, we've got our bureau token, our JWT token, which is bigger than a small ID, obviously. But if we go now and we get this token, and we go to jwt.io, for instance, if we look at what we have inside the token, we'll find again the three parts that I described earlier in this presentation. The first part, which is the header, where we have all the information that we've seen on the UI of the API gateway, so the name of the key, the type of the token, and the algorithm. On the payload, we can see the subject, which is Alex. We can see the list of groups, which are create, update, delete. If I go now to the UI of the product and I add a new role and I do another authentication, I'll get a new set of groups that I'm going to be able to use on my application. And we've got also the expiration date. So if we go over here, it should be in 5 minutes. Well, 3 minutes now because I've been talking. But basically the expiration date is 5 minutes after the issued time over here, which is what I've configured in the API gateway, right? So if now I log out and I take another account over here, let's say that I'm going to use Mark. Mark should not be able to do deletes, for instance. I don't remember what Mark is able to do. Not this one, sorry. Accounts. So Mark can only do updates. So that's why I got a permission denied if I try to delete. Mark should not be able to add anything either. Ah, sorry. Okay. So Mark is not allowed to delete anything as well, but oh, it's very big. But Mark should be able to go into a movie and add a comment at the end. Well, there are a lot of comments in this one. Yeah, I'm using a library named Java Faker, which is kind of nice to generate some random data. So yeah, Mark, as you have seen, is able to do updates on the movies. So now if we go to the application itself, here I go, oops. It's not very handy. Hold on, I'll be showing maybe. Oops. This one. So what you need to do first when you want to use the MicroProfile JWT implementation is go on the JAX-RS application and basically add an annotation which is going to trigger the extension. So you're going to be adding the @login config, and then you need the keyword mpjwt in there. As soon as you do that, basically it triggers the extension, and then every time you're going to do a call, the extension is going to check the header on the HTTP message, extract the token, pass the token, validate the signature, and then if you have some annotations like roll the load, here we go. So if you get some annotations like roles allowed, the extension is also going to check if in the token you have the role or the group update in there. If you don't, then you're going to be receiving a 403 on the client side, which means that you don't have the role and you don't have the permissions to do the call. So the extension also allows you to inject claims from the JWT very easily. So the way you do that is you use the regular @inject CDI annotation, and then you add the @claims, and when you do that, you can specify the name of the claim you want to get, and the extension is going to extract that information from the JWT and gives you the value. You can get also the full JSON web token interface, which is an extension of the principal interface from Java EE. The JSON web token interface defines a set of standard methods like get issuer, get audience, get subject that allows you to read on a standard way all the claims from your token. And therefore you can using this JWT principle check first if a user has been authenticated or not, because if it's null, it hasn't been authenticated. But you can also extract all the information and build up your audit trail if you want. You can use that into your business logic to store information about the user. Like when I had a comment to a movie, I need to set the username and the email so that we can display the nice gravatar in the UI. And to do that, I won't be asking the user to fill in the username and the email. I'll be extracting that information from the security context, which is the JSON web token. So overall, it's very easy and to use. You just need a notation to trigger the extension. You need obviously a compliant implementation, so Liberty Profile is one of them, Apache TomEE is another one, and you have one as well on JBoss Swarm. So there are already plenty of them that you can use. The only thing that you need to do is activate the extension, and then you can define roles, you can get claims injected and have your business logic implemented. Where is my presentation? Well, I don't know where it is. There we go. That's it. I'm sorry it's been a bit longer than I was expecting. 35 minutes is very small to have an interesting presentation. I hope that you learned something today, and if you got any questions, feel free to reach out to me. I've got some MicroProfile t-shirts as well, so if some of you want some MicroProfile t-shirts, I have maybe 10. So come over and I'm happy to give you a t-shirt as well. Thank you very much for coming. There are some evaluation as well. Thanks.